Making a game from scratch, part 1. We'll start by setting up a basic prototype level so we can build a movement system. We can iterate through all the points on the level to map the walkable area into a nodal network. The nodal network is going to be a useful tool for telling our AI how to navigate and move around the level. We're generating the network by splitting the level into a grid. At each point, we check the cell above, below, and either side of the point to determine how many connections it has. If the cell has 2 connections, it is just a connecting pathway. If the cell has any other number of connections, it's a node or junction. This is a decision-making point where our AI can choose which way to go. In part 2, we'll look at adding some AI and getting it to move around the level. Thanks for watching, like and follow for more. Making a game from scratch, part 2. I've added a couple of AI bots and a player control character which I can move around with the arrow keys. I'm using Unity to make this, which already has a navigation system. We can use this to make the bots take the shortest route to the player. By overlaying our own nodal network from part 1, we can manipulate our bots to take specific routes. It makes sense for one bot to take the shortest route to the player, but the other bot would be more useful if it took a longer route which covers different ground to help cut the player off. If we calculate the shortest route using our nodal network for the closest bot, we can avoid as many of those nodes as possible when looking for an alternate route for the second bot. Tune in for the next part where I'll probably do some 3D modelling. I'm thinking of maybe making this into a card game, so like and follow to see how it goes. Hey guys, so I've been looking at the logic for the AI to chase after the player, so every time the player travels a certain distance, the AI recalculates the route to get to the player. The only problem is the calculation is quite memory intensive, so it leads to these little lag spikes in the game. But we can solve this using the Unity job system, and what that allows us to do is something called parallel processing, where the calculation can be done on one thread while the rest of the game logic runs on another thread. And so we can take a look at what that looks like. And the gameplay just ends up being a lot smoother. Really hope you enjoyed the video. Like and follow for more. I've replaced the placeholder assets with the cars from part 5, so now we need to put some movement mechanics in so the player moves like a car. At the moment, when the player puts in a sideways input, the car moves sideways. Instead of this, we can change the sideways input to apply a rotational force, and we get something that moves a lot more like a car. And the AI was already turning using the Unity NavMesh agent, so now we can get some better looking car chases going. So I found this cool city building set in the Unity asset store, thought I'd write a little algorithm to populate our level with all these assets. So the algorithm just puts a random building in each spot facing a random direction, and then for the road, it's not random, just picks depending on how many connected spaces each bit of the level has. And now we've got something that looks a bit more like an actual level.